All right, welcome everyone. Thanks for coming. So this talk is on building modern web applications with Play and Scala. Who here has used Play before? Wow, awesome. Okay, so for those of you that have used Play, this may be a little introductory for you, but at least the whole presentation is no slides. I'm just going to write some code, and we can kind of take that where you guys want to go. So I've got a little bit that I'll get through, and then we can go from there. To set a little bit of context, the way that we build web applications is changing. Obviously, we're doing kind of going back to the client-server architecture for most of our web applications, where we have RESTful JSON services on our server, and then we write JavaScript UIs or mobile UIs on top of those. So Play supports that very well, and so I wanted to go through, first starting out, just creating a new application, show you how to do that, and then showing how we build in Play these new types of applications that have a JavaScript front end for a JSON service backend. So that's the tentative agenda. We'll see how that goes. If you have questions or have other things that you want me to cover, feel free to raise your hand and ask those and give me feedback as I go. So let me dive in and start building an app, and let me get my screen recording going. So with Play, the typical way to get started with Play is to download Play from playframework.com. You get a zip file, and then add the contents of that zip file, extract it to your hard drive. You add that to your path directory, so that then you can just run the Play command. There's another new way that Typesafe has been working on to get started building Play applications called Activator. It's a way to get started with template applications and start building your applications in a local web interface, local running web interface. I'm not going to be using Activator today. Usually I use Activator, but I discovered a bug in Activator that would be annoying, and so until I get that bug fixed, I'm going to be using the Play command instead. So to create a new app, Play new, and I'm going to call this one foo, and then I'm going to make a Scala application. So there's my app is created, so it's in the foo directory. There we go. So before I open up this app into my IDE, I'm going to use IntelliJ. I'm going to edit the build configuration file to add a few dependencies that I'll be using later. So, and I have a cheat sheet on a gist, so I'm going to try to do most of this without using my cheat sheet. But the build file is in project build.scala, so this uses SBT. Play uses SBT to do its build. We were just talking before I got started about support for other build tools, Maven and Gradle. Today we don't have a good way in Play to support those other build tools. Really, SBT is the main build tool for doing Play stuff. So this is the SBT configuration file. I'm going to come in and change my dependencies here, add in a couple. So I'm going to be using for persistence the SORM framework, Scala ORM. I'll be using WebJars. I'll tell you about that in a little bit, and Bootstrap, Twitter Bootstrap. So now that I've updated my dependencies, what I'm going to do, oh, and there's one more change I need to make here. I also need to set the Scala version. The SORM framework doesn't deal well with multiple versions of Scala, so I'm going to change the Scala version for this app to be 2.10.1. Okay, so now I'm going to run play idea. This will generate my IDE descriptor files. You could also type play Eclipse to generate the Eclipse files. And then I'll be able to open this up in IntelliJ. The way that I usually do development with Play is to use the command line for being able to run the application, run the tests, and then I do my code editing in IDE, usually IntelliJ. But you can choose however you want. A lot of Play developers use Sublime Text or just regular text editors, and I'll show you how Play makes it easy to use, really just a plain old text editor when you're building your application. So there we go. Let's go open it up in IntelliJ. So come in here to desktop and go open up foo. So now while that's opening up, let's go back here and run the application. So when you run a Play application, you can either do play run or you can do play twiddle run. The difference between the two is that twiddle run watches the file system for changes, and on file system change it automatically recompiles based on file system change. Play run waits until you hit refresh in your browser to do the recompile. And so the time that it takes me, the like 400 milliseconds that it takes me to get from my IDE to my web browser and hit reload, by the time I usually get there and hit reload, the compile changes have already happened. So that's why I prefer twiddle run. But when I'm on an airplane and battery power is a valuable resource, then I usually just do run, because there's certainly a lot more compiling going on if it's watching the file system for changes, especially because IntelliJ automatically saves changes all the time. It's like whenever you leave focus from IntelliJ, it saves changes. So, okay. So now my app is up and running. Let me go check this out in the browser. So localhost 9000 is the default. So first it will compile this application. While it's compiling, let's go take a look in here at what the code looks like. And let me, before we do that, let me increase my font size in IntelliJ so you can see that a little better. Okay, so let me walk through the basic parts of this play application before we dive in and start making some changes. So first, app is the main source directory for this application. So, so this is, if you're familiar with like source main Java or source main Scala, this is a combined source directory for play. This is a default. You can change that to be any directory structure that you want, but for play, the default is app. I personally like having my Scala and Java classes, source files in the same directory structure, but if you want to separate those out into separate ones, you certainly can do that. So in app, I have some Scala source for this application and some server-side templates. I'll walk through that more in a couple minutes. And then the conf directory, I have my main configuration file. I'm not going to do anything in this configuration file today, but this uses Typesafe config, a library for managing your configuration. It allows you to change your configuration between a test environment, production environment, and so on. Then I have a conf routes file. The conf routes file is where I define a mapping between an HTTP verb, an HTTP path, and then the code that actually is going to handle that request. So this is where play is just a RESTful framework by default. When you define your mappings, you're defining them in a RESTful way. You're defining the verbs explicitly, you're defining the paths, you can do substitution, value substitution in the paths. So, so it really puts us close to the HTTP protocol. If you're familiar with traditional Java web application development, a lot of the web frameworks try to hide the HTTP protocol from you, whereas play gets you working directly with the HTTP protocol. So if you're building REST backends, it's perfect for that sort of thing. So the routes file is actually compiled. Everywhere that play can use type safety in a compiler, it's going to do that. And one of the nice things about this is that I'm going to get compile errors if I screw up the syntax of my routes file. So, so let's take a look first at the browser. So there's my application, my default application up and running. That's great. How that got handled was by my browser made a GET request to /, and then that was handled by controllers.application.index, right? And if I go in here and I make a change to this file, let's try to go back. Well, that would be a compile error. Oh, indexing. Come on, IntelliJ. Let's. There we go. So if I make a change to that file, if I hit reload in my browser, anytime that there's a compile error, play is going to show me that compile error in the browser, and it's going to show me the line number, it's going to show me the error message in a really nice way. So this is how you don't have to use an IDE with play. A lot of people don't, because we see the error messages in a really nice way in the browser. You only see these error messages when you're in development mode. So when you're in production mode, your users are not going to see your source code leaking out. So we don't have that kind of security issue. So one of the other nice things about this file being compiled is that play compiles also a reverse routing table. So this is the forward routing table that play uses to figure out how to route requests. But a lot of times in your code, you need to reference URLs throughout your application. If you need to do a redirect or something, you need a URL to know what to redirect to. And the way that I used to do this is have strings that contained my URLs, and I'd change routing information in one place and then forget to change it in the strings. And so that obviously it results in regressions in applications, and I've experienced this personally. It's not very fun. So what play does to avoid that is to actually compile the forward routing table into a reversed routing table. So now in my code, whenever I need to specify a route, I actually use a compiled class that's derived from this so that if I refactor my routes, it's automatically going to be reflected throughout my application. The routing syntax is pretty flexible. You can do substitutions in here. This would take everything through the end of the line. You can also do just a single part of the path substitution. You can do regex, so a number of different things here. And of course, you can do all the different verbs as well. So we'll see that in a couple minutes. But before I go on, any questions about the routing syntax in play? One thing about the routing is that this is the default routing mechanism in play, but there's an easy way to override routing and do your own custom routing as well. So if you don't want to use Play's routing syntax, there's a couple other projects out there. There's Play Navigator. There's one that takes the JAX-RS annotations for doing routing and uses that instead of this routing this routing file. So up to you how you ultimately do routing, but this is the default syntax. Yeah.
So if I want to do some client-side routing and I just want to have them, like I have a one-page app, can I use some like a backbone router on top of this? Yeah,
definitely. Yeah, so there's a few different ways to handle that. One of the ways is that one of the things that Play compiles when it compiles the routes file is it compiles a reverse routing table for JavaScript. So this will actually create a JavaScript file that will contain all the reverse routing information into it, and so then you use that routing table to hook into Backbone's routing, or we use Knockout for Activator. So we build all on top of that JavaScript reverse routing table. That's one way to do it. There's also, if you're using WebJars, there's support for require.js, and require.js will automatically use the reverse routing table and automatically set up the require.js information so that you can just use require.js and not have to worry about any paths on your system. So there's definitely a lot of different ways to handle that, but it works well with Backbone, Knockouts, all the kind of modern routing, client-side routing systems. Yeah, go ahead.
If you put less files in the assets directory, they should build automatically, right?
I'll get to that. Yep. Yeah. But yeah, there's the asset compiler that I'll cover in a few minutes. Yeah.
Where do you configure the environments in production versus developer?
So there's a few different ways to do that. If I wanted to run this application in production mode from the command line, I would type play start instead of play run. That's one way to do it, but if you're creating like a distribution to put on a server, it's a different way to start the application. Yeah. And then you can also specify a different configuration file to run play under from the command line. So you can say play -d config.file equals, give it a different config file, and then say run. That's right. Yeah. Okay, so that's the routing syntax. Let's go take a little bit deeper look at what's actually going on here. So I'm routing this request. That's great to that controllers.application.index. So here's that Scala class that's doing that. It extends controller just to bring in some convenience methods. You don't have to do that if you don't want to. And then I have my method here, index, which creates an action, and action is the thing that's going to return the response. And so in this case, the response that I'm returning is OK, which means status code 200. If I wanted to get a 404, it would be not found. And then what's actually being returned in the response body is what I'm passing in here. So this is a server-side template. We'll take a look at how that's generated in a minute. But one of the things I want to show you is that if we take a look at the string on the page, let's go refresh this, you'll see that the string is coming in here. Your new application is ready. So if we change this string, so say hello world, and just save that. So as soon as I save that file, Play's going to automatically recompile that, and now we see the change there. So this is the workflow with Play. You don't have to rebuild WAR files, redeploy WAR files, restart Tomcat. You just hit refresh in your browser and you see your changes. That also works for Java. I'm using Scala here, but the same thing is true for Java. Okay, so I'm using a server-side template. So in a views package, you'll see that there's an index.scala.html, and this file is a server-side template in Play. Server-side templates in a modern web application aren't very oftenly used. The main reason I'm using them here is one, it's the default, and then another one is, I'll show you another file in a second, but I'm using server-side templating to get the routing information for the assets that I need for the client side. So this server-side template, it's written in Scala. It's a Scala HTML combined thing. it's the default templating language in Play is Scala with HTML. You can swap that out for any other templating language. Scala makes a pretty good templating language in our case because it's type safe and it's a pretty simple syntax for being able to do composition, functional composition of templates. So first, the first line here is the parameter that this template takes, and then the second line is another template that I'm going to compose into this one. So what's actually happening is that Play has a template compiler that's compiling all of the templates that I have down into Scala functions, and then I can compose together those Scala functions and use those Scala functions just like I would any other function. So at main is calling the main template. So you'll see that this template takes two parameters. There's a string and then a content block, and then this is the main body of my page, right? But it's taking that content block and putting it into the body part of that page. So the first, the parameters here, this is the first parameter, and then this is the second parameter. So in this case, what's actually being rendered in this page is the Play to welcome message. This is another server-side template that's actually included in Play to render the documentation and render that first page that we are seeing. So we can come in and make a change to this. Let's say that we don't want to see that. We just want to see the message parameter there on the page. We can make a change, and just like before, Play is going to recompile that template, and I just hit refresh and see that change. Okay? So that's the server-side templates. Any questions on those before we go on? Okay. So we've got our templates. There's a few other things I want to point out here. Public is the directory for static assets. What happens in this case with Play is that the static assets go into jar files essentially. And so this becomes something that's available in the class path, and then Play's static asset handler actually pulls files out of the class path. So that's how we do static assets in Play. Then there's a test directory here, and the test directory contains my tests, obviously. It's a combined directory structure, so instead of source test Java, source test Scala, we combine them into just a test directory. You can, of course, override that and change that to be whatever you want, but the default is just test. I'm not going to show the testing support too much today, but Play's testing support is pretty extensive. It allows you to test your routes directly, test your controllers directly, test your templates directly. That's one of the nice things about using compiled templates is now I can actually write a test against a compiled template. You can also use Selenium. You can start up an actual Play server and test that with actual HTTP calls. So lots of different levels of doing testing in Play. The way to run tests is let's go over here. If I type play test, this will just run the test once. Usually when I'm developing a Play application, I run with play twiddle test, and that twiddle says keep that test session open, and whenever any source or test code changes, then recompile and rerun the test. And so I always usually have a twiddle run window and a twiddle test window, and if I want to see my test output, then I just go check it out. It's going to run automatically. And one of my tests is now failing because my test is looking for your new application is ready, and I changed that string to hello world. So anyways, so that's the testing support. Any questions about the testing support before we go on? Yeah.
So can I integrate with SVT test or?
So yeah, good question. So the play command, all that it really is doing is wrapping SVT. So everything that I'm doing with play something, it's really just SVT. And so running play test is the same thing as running SVT test. So the reason why Play has this wrapper on top of SVT is because it applies some additional SVT settings for you. That's really all that it's doing. But you could also just run SVT directly on this project, because really at the end of the day, it's just SVT.
Nice.
Yeah. Yeah.
Hi. So I'm a Scala and a Play newbie, so
okay.
It's a newbie question.
Yeah.
Can you swap test frameworks around, like something like spec, RSpec, and
yeah, good question. So Play supports anything with a JUnit interface, okay, just like SVT does, because that's how we run the tests, is through SVT. So anything that has a JUnit interface. So the default testing in Play is Specs2 for Scala and JUnit for Java, but you can easily put in Scala test or put in anything that complies to the JUnit interface for testing.
Thank you.
Yeah, and you just drop those tests in the test directory and run your tests and you're good. Yeah, good question. Other questions before we dive more into the modern web app side? Okay. All right. So that's your basic primer to getting started with Play. So now I want to take this a bit further and start building up more of a modern application to show you the different pieces that Play supports for doing that. So first, what I want to do is create a model. We have to have some data to play with, so I'm going to create a new model. So we come in and create a new Scala class. This is going to be models.bar. Whoops, and that's not exactly what I wanted to call it. That's okay. It doesn't. I get really anal about naming stuff. Did I just copy and paste something to a file? There. We'll see if that screws up something. Let's, one sec. App models. Where'd it go? Oh, gosh. Totally screwed that up. Okay, let's try this one more time. New Scala class, models.bar. There we go. Okay, so what I'm going to do is create first a case class. So, case class bar. And what this app is going to do is store my favorite list of bars. And so I just need a name property here on each bar. It's a pretty basic data model for this one. And then I'm also going to do some JSON serialization. So let me show you how we set up the JSON serializers and deserializers in Play. In Play Java, you don't have to set up the serializers and deserializers because it uses Jackson and does reflection. In Scala, we want to avoid reflection and have the JSON part of Play is really powerful, but we do have to create the JSON parsers and serializers and deserializers. So to do that, I'm going to create an object called bar, and I'm going to create in here an implicit val that's going to be my rights. The rights is what will create a JSON string from an object. So what I do, the easy way to do this is, let's first import that thing. I'm going to create a JSON.rights. Oops. There we go. Okay, a JSON.rights of bar. This is a new feature in Play 2.1 where in Play 2.0 I had to explicitly create the actual serializers and deserializers. It was a lot of boilerplate code. It wasn't very fun to write. So now in Play 2.1 we're actually using macros in Scala to be able to generate that boilerplate for you. So if you have a straightforward serialization and deserialization, you can just say create the JSON rights of this object, and a macro is actually going to fill that in for you. You can also explicitly define your serialization and deserialization. So that's the easy way to do that. Let's create another one here. That's going to be the reads. So the reads are going to be able to parse a JSON string into a bar, and again I'm going to use the macro to be able to do that. Okay, so that's a super simple way to do JSON. There's like probably 40 pages of documentation in the Play documentation about how to do JSON and all the different JSON features and JSON structured traversals and JSON. There's something cool called JSON coast to coast. So this is a pretty cool concept where if you have JSON coming from a backend data store, whether that's through a web service or whether that's MongoDB or something like that, you don't need to have intermediary objects that you're transforming that JSON into and then transforming out into some other format. JSON coast to coast just allows you to work with raw JSON in a really nice Scala DSL to be able to do JSON transformations and combine two different JSON objects into one object with different fields excluded. So there's some really powerful things in the Play JSON Scala stuff. I'm going to stick with the basics today, but if you have any specific questions about Play JSON, I can try to answer those. Any questions about Play JSON? Yeah? Oh, thank you. Yeah, it's always good to have massive pair programming going on when I'm live coding. Thank you. Questions about Play JSON before we're gone? Okay, so we've got our companion object there that will do our JSON serialization and deserialization. I'm also going to create an object that will use SORM to do persistence. So to do this, I'm going to create a new object called DB, and this extends instance. There There we go. And then this takes some parameters. So the first parameter is the entities that I want to be able to work with in SORM. So this will be a sequence of entity of bar. Let's go import that. Okay, so that's the first parameter there. Entity. There we go. There it is. Okay. Then I need the connection string. Usually I would pull this out of the application comp file at runtime, right? Parse the configuration and use the configuration here. But I'm just going to do it the easy way and put in here the URL directly. So I'm going to use an in-memory database for this one. So that's my connection string to that database. So that's SORM framework, pretty easy to set up. So you could also use any kind of persistence framework that you want. With Play, Scala, the default persistence framework is called ANORM. ANORM stands for ANORM is not an ORM. So it's great because you can work directly with the JDBC structures and write your own parsers for parsing rows. And it's just a bit more, it's powerful, but it's a bit more verbose than I want to spend time on today. So that's why I chose to use SORM instead. There's a number of other persistence technologies out there. Relational persistence. If you're not doing relational, if you're doing Mongo, you get into some really interesting things around, there's a plugin for Play called Reactive Mongo, which is a fully async and non-blocking driver for Mongo. So there's some pretty cool stuff out there for doing persistence in all sorts of different ways. But today, I'm going to use SORM because that's an easy one. Okay, so I've got my bar object. Any questions about this before I go on? Okay. So the next thing we need to do is create some controller methods that will allow us to add a new bar and to fetch the list of bars out. So first, let's write the add bar one. So I'll just call this add bar. So this will be an action. But this action is going to parse JSON. So I can tell it the parser to use. So I'm going to say parse.json. Okay? So you can tell, by default, Play will just use kind of the generic body parser, but if you explicitly set a body parser, then it makes it easier to, you don't have to in your code, say which body type to use. It's automatically just going to throw an error if it can't parse the request body. Okay, so what I'm going to do is I need to get my bar out of the request body. So let's create a new bar. And what I need to do is get the request body. So to do that, I'm going to add the request here. And then I'm going to say request.body. You'll see that is a JS value, is the type of that. The reason why it's a JS value in this case is because I set the body parser to be JSON. Okay, then I need to take this object and I need to parse it into a actual bar object. So I just say as bar, and let's go import that. There we go. And so now that bar will be an actual bar instance of that bar case class, right? But what I really want to do is I want to save this new bar into the database. So to do that, what I'm going to do is do db. That's that database object that I created. So let's go import that. And I'm going to say save this thing. And that's it. So now that bar is actually going to be the way that SORM works is that it gives me back a new, an object that is not just a bar case class, it's a bar with persisted. And the with persisted adds an ID field to that object. So pretty cool way to do that. But now that's going to be my bar, my saved bar file that should have been saved in the database. Okay, so now what I want to do is return a response back to the user. And in this case, there's a lot of different things I could do here. I could do a redirect or just return a OK 200 response. But in this case, I'm going to return the actual bar that was created back to the user. So I don't really need to do it this way, but I want to show you how we do the JSON serialization. So I'm going to do JSON, and let's import that, .toJSON, whoops, to JSON. And then I'm going to give it the thing to serialize, and that's a bar. There we go. So now automatically what that'll do is it'll look for something that can serialize a bar into JSON. And because I'm using the companion object that has that implicit write, now it's going to be able to find the serializer that it needs to be able to turn that bar object into the JSON. Because the response or the output of toJSON, let's take a look, is actually a JS value. Play will know, hey, oh, you're giving this thing this OK, you're giving it a JS value, so it's automatically going to set the content type in the response to be application JSON. So that happens for us automatically. One of the other things to point out about this is that oftentimes what we want to do is return a different content type based on what the user has asked for. So if a browser is making a request, then the accepts header, what the user is asking for, will be HTML. And so we may want to return an HTML representation of this object rather than the JSON representation. So Play 2.1 now has a way where you can use a match on the request accept header and then return a different format pretty easily. So pretty nice feature if you want to be able to handle different content types in these methods. Okay, so that's the add method. Any questions about that before I go on? Yeah.
Exceptions, errors if the data was not
yeah, good question. So this obviously is assuming that we're never going to get errors, which is a bad assumption. But I believe that db.save will either throw an exception or there's something on the with persisted that will tell us whether or not that actually did save. So we would obviously have to check that, and then if that didn't work, then instead of returning OK, we'd return internal server error with some error message back out to the user. So we can certainly do that. There's a number of different ways to handle the failure depending on what framework you're using. A lot of times when we do asynchronous programming in Play, we handle the failure at the future level. So if the future doesn't completes with an error, then we handle that and return a nice error message back to the user. So there's lots of different ways to do it, but in this case, there's probably something in SORM that we would key off of to know that there was a problem saving. In futures? So relational databases, most of them don't have a way to do async non-blocking requests to them. So in this case, we could wrap this up into a future, but it doesn't really make a whole lot of sense because we're going to be blocking on talking to the database anyways. When we get into reactive Mongo, which is an async and non-blocking way, then something like save would not return a response immediately. It would return a future of the actual object to be saved, and then we'd have to set up a way to handle the complete event on that future. So yeah, this is assuming that we're doing all blocking things here. Because relational databases, we essentially have to be blocking. But when we get to reactive Mongo, we certainly could use futures and be async and non-blocking throughout the whole thing. Play has a way to also have the request handlers, the controller handlers, also be async and non-blocking. So the way that we would do that is if we want this method to be async and non-blocking, we'd say async, like this. And then we no longer can return an actual result. We have to return a future of a result. So I could, create a future around this thing. But underneath the covers, this is actually working the same way as before because there's actually nothing really asynchronous about this. But so you certainly in Play can tell your controllers that they are async and return a future of a response rather than the response.
But it won't work because it's using.
This definitely works. Yeah. So if I go reload execution context, let's go import that thing. I'm not going to spend time on that, but it certainly will work. This is actually exactly what Play does underneath the covers. But in this case, we don't need to have the additional stuff there because we're not actually doing anything asynchronous in this case. Yeah. Okay. Let's continue on. Let me go.
What is it actually using the covers to do async? To respond to the WebPage WebSockets?
Good question. So Play is built on Java NIO, and Netty is the implementation. And so that allows you to not have a thread per connection. So what technically would happen if we were doing something async and non-blocking, The request would come into the server would go off and do something, but in the time that we're waiting to send the response back out to the user, we're going to take that thread that you normally have to keep allocated, we're going to give it to somebody else to let some other request be handled or whatever. And then as soon as the future completes, we're using all Scala futures for all this. As soon as the future completes, then we'll get a thread back and send the response back to the user. So it's all built on Java NIO. We also have in place support for WebSockets, which is also built on futures and async and non-blocking and Netty and Java NIO. So from Play's perspective, it doesn't matter if it's a regular request or if it's a WebSocket or a comment channel or whatever. It's all async and non-blocking underneath the covers. Yeah. Okay, so let's keep moving here. So next, I want to create a method that will return the list of bars. So let's say def get bars. And we'll create an action. Now what I want to do is get my list of bars out of the database. So create a new val called bars, and this will be db.query. I'm going to query for my bars and get it to fetch just all of them. So there we'll get all the bars out, and now I'm going to return a JSON response. So JSON to JSON, and give it my bars. There we go. Okay. So that's all I need for my controller to be able to do add and get all. Obviously very simple, not the full REST scheme with delete and update and those sorts of things, but when it's not too hard to add the rest of those. So the next thing I need to do is add routes in to define the mapping, the URL mapping to these. So first let's do a get handler for /bars, and that's going to go to controllers.application.addBar. And then let's do another one that's going to get the bars. So we'll come in and make add bar shouldn't be a get, should be a post. There we go. So post to /bars is going to call add bar, and then a get to /bars is going to call get bars. If you're doing RESTful style stuff, the way that Play's routing syntax is set up, where I have to define a new line for each of the different methods, becomes a bit cumbersome in REST. So there is a way where you can actually create you use a different syntax. You use like minus greater than to set up like a REST controller that would have the typical REST methods on it, and then you'd be able to map all of the HTTP verbs that are needed to that. So there is a syntax for doing that, but it's not integrated. That syntax isn't fully integrated into Play yet. There's some blog posts on how to do it out there, and it's something that we're looking at integrating just as a first-class citizen into the Play. Okay, so that's our routing syntax. So if we go try this out, if I go to /bars, then what we should see once we get a database created is, very exciting, an empty array from JSON. So that's a JSON array that has no objects in it. I haven't created any bars yet. So great, so now I have my back-end services that I'm going to use to now build a front-end application on. So let me go on to the next part, where now let's create the actual front end to this application. So first, let me go into my index.scala.html, and the UI that I want to display, and I'm actually going to copy and paste some of this to save a little bit of time here. The UI that I want to display is just going to be this form that allows me to add a bar and then an unordered list that's going to display my list of bars. So I'm still writing my, I could be using some client-side templating language. In this case, I don't need that. I'm just using, in the base HTML page, I'm rendering that HTML. Okay, so I've got that. Then what we need is the JavaScript that will actually produce the actual interaction on this page. So Play has an asset compiler built into it that can compile CoffeeScript into JavaScript. It can compile JavaScript, so basically just syntax check JavaScript. It can compile less into CSS, and then you can also plug additional asset compilers into it. So I'm going to create the actual JavaScript in CoffeeScript. So let me create a new package here. The package is assets.javascripts, is the directory that Play keys off of to compile both CoffeeScript and JavaScript. So in here I'm going to create a new file called index.coffee. And then again I'm going to cheat and just copy and paste the client side. I'll tell you what this is all doing. So first I have a get bars function. All that it does is make a get request to /bars, which should give me my JSON data with the list of bars, and then it iterates through each of those and puts each of those items into that UL that I defined in HTML. So there's some jQuery stuff there. Obviously there's a few ways that this could be better. One is that I'm hard coding the URL /bars. I should be using the reverse routing table to do that. There is a way with Play, as I was saying earlier, to do the JavaScript reverse routing table and pull that in. It just takes a couple other steps. And then the other thing is I should be using some client-side templating to do this instead of doing jQuery DOM manipulation to render the page. Okay, so then when the page loads, I fetch the bars, and then I set up an event handler on the form that's in the HTML. So when the form is submitted, what I do is I assemble my request to the server, which goes to the URL is /bars as defined actually on the form. I assemble my JSON, and then on success, I just refresh my list of bars, and then turn the input value back to nothing. Okay, so that's the client side of my application written in CoffeeScript. So let me show you how to bring that into the actual page. So if I go to my HTML page here, and I want to now pull that compiled file into my page, the way that I do it is I say, I'm going to load in index.min.js. Index.min.js doesn't actually exist anywhere in my source code, but this is what Play is actually doing, is it's taking that CoffeeScript, it's compiling it down into a JavaScript file, it puts that .js file into the class path so that the static asset controller can get to it, and then it also creates a minified version of that JavaScript file and also puts that into the class path so that the static asset controller can get to it. Okay, so let's give it a try. Let's go see if everything works as expected. So, gotta go to the actual app here. So there we go, there's our beautiful form to create new bars. So let's go create a new bar and cross our fingers. There we go, yay. So I'm adding bars. So what's happening is it's listening for this form submit. The JavaScript is listening for the form submit, making the post request to the server, sending it as the JSON string up to the server, that's saving to the database, and then the response should contain the serialized JSON that I added to the database. But then I'm essentially ignoring that and then just refreshing the list of bars. So if I hit reload, right, it's just loading up that list of bars. If I go now back to /bars, now I see my serialized JSON for those objects. Okay, so that's my functional application, but have a couple minutes left to make it look a little bit prettier, and I want to show you some WebJar stuff. But before I go into that, any questions about how the asset compiler works and that stuff? Yeah, go ahead.
It's easy to get an unminified version of the file.
Yep, yeah, so if we come in here and we change this to index.js, that's the non-minified version, and it should still work the exact same way. Usually what people will do is they'll wrap that in the server-side template where I'm saying load in index.min.js, they'll wrap that in a function call that based on a configuration parameter will say whether to use the minified versions or the non-minified versions, depending on if I'm in development or production. And then the other thing that you can do is hook this all into require.js. Play has support for require.js, and so you can also just do this all through require.js and let require.js manage that for you as well. So a number of different ways to handle that depending on what you want to do. Yeah?
You were saying about the less files, would they end up in the same place? So you'd be
yeah, oh yeah, so let me show you that. So the way where I would put less files is in assets.stylesheets, and then those would be loaded in the same way that I'm loading in the JavaScript. Right now I'm loading in a CSS file that's main.css, which comes from my public directory. You'll see down here, that's main.css from my public directory. If I had instead created a less file in assets style sheets and named it main.less, then I would actually load this in the same way. I'd have to remove the one that's already there, but
would it end up in your main/style sheets directory? Or
you don't actually see the compiled versions. They're somewhere in the SBT target directory somewhere, so you don't actually see those directly. But they're available through this the static asset controller in play, the assets controller in play.
Okay. Is there any way to get them though if you wanted to?
So you can either get them through your browser, like if you go to, let me show you how that routing is set up. So in the routes file, we have this mapping that says map request for /asset/something to the static asset controller. So I could go in my browser and say localhost / let me show you, localhost / assets / style sheets / main.css. And actually this file's empty, so nothing in there. Let me go make a change to it. Body, padding top, 50 pixels. Okay, and hit refresh. So you can either get to those through your browser, or you could go find the compiled files that are in the target directory that Play is actually serving that file from. So you can do it either way.
Can I see that configuration real quick for the
routes?
Yeah, the routes.
Yeah. So this is in a Play application. When you create a new Play application, it automatically will have this route syntax in it to go to the static asset controller. But you can set up your own router, your own routing for static assets however you want. I'll show you another way to do it with something called WebJars right now.
Quick announcement. So the next token is in basically 7 minutes. So if you can wrap up in a couple of minutes, if you guys want to stay here, stay here. The next talk starts 11 sharp. So basically, if you ask more questions for James, you can ask him in the breaks, and then basically use this opportunity to change room if you need to, please.
Okay. So we don't have a break between sessions. So we're not going to have time to go through the WebJar stuff, but if you go through, there's a few different ways you could learn about the next step, which is to set up your client-side dependencies for your application called WebJars. If you want to learn more about that, just go to webjars.org. It's a way to pull in client-side dependencies into your application. But yeah, so that's how we build modern web apps with Play. If that was useful.